Hello everybody. Today I can prepare for my triangles proofs test by practicing. It all comes down to knowing how to do triangle proofs. If you know how to do them, this is it. We start with a multiple choice question for perpendicular bisector. For perpendicular bisector, you need to know it's going to be this picture, where if AB is the perpendicular bisector, AB is doing the cutting, CD is being bisected at point M. Now, you need to know that the two top triangles are congruent, so the greens are congruent, the reds are congruent, and then the top, the purple, and the bottom, the blue, are both isosceles. Keep in mind that if those two greens and two reds are congruent, that all the corresponding parts must be congruent as well. So, CB, DB. CB is congruent to DB. That is correct for two reasons. One, this blue triangle is isosceles, and two, those triangles, the two red triangles are congruent, and those are corresponding parts. Let's go through the rest of the choices. C, D, A, B. No, there's no reason to believe those are the same. As you can see in my picture, they're definitely not the same. Triangle ACD. So ACD is the purple triangle. Is congruent to BCD, the blue triangle. No, they're both isosceles, but I don't know that they're congruent. And ACM is the green, one of the green triangles, is congruent to BCM. That's one of the red triangles. No, that green and red are not the same. Choice one is the answer. Again, when you see perpendicular bisector, there's your side that's being bisected. There's the bisector. The two top triangles are congruent. The two bottom triangles are congruent. The top triangle is isosceles, the bottom triangle is isosceles, and all the corresponding parts of the congruent triangles must be congruent. So you'll see one of those. That brings us to proofs. Let's just get this over here. So you're going to have one straightforward proof, no additional tools. That's this. We're always proving triangles are congruent. Is it obvious which triangles I'm proving congruent? It is to me. I've got the blue triangle, and I've got the red triangle. So, statements. Reasons. NB bisects angle IBO. That's my first given. I take my givens, I do many proofs. NB bisects angle IBO. Given. Well, that's an angle bisector, so I write down my angle bisector definition. An angle bisector creates two congruent angles. So if B is what's being bisected, those are my two congruent angles. I got angle IBR, and I've got angle OBR. I've got one pair of things congruent. I need three. I go to my next given. BR is perpendicular to IO. Given. I do a mini proof. Perpendicular lines form congruent right angles. There are my congruent right angles. Angle BRI is congruent to angle BRO. Now I have two pairs of things congruent. I need three. I'm out of givens, so I move on to my additional tools. VRIAS. V, vertical angles, no. R, reflexive property, yes. BR is congruent to BR. Reflexive property. Now that I have three things congruent, that's what I wanted. I did it. I prove that the triangles are congruent. So I'm going to state that triangle, it doesn't matter how I name the first one, but the second one, the letters must correspond. So if it went IBR, I have to go OBR. I proved angle, side angle. Two angles and the side between them. Remember, we can just kind of like block out one of the triangles. So I'm looking just at the red triangle and I see two angles and I see the side in between. Got angle, side angle. And now that the triangles are congruent, I can state any of the corresponding parts, including angle bio is congruent to angle boy. And the reason corresponding parts of congruent triangles are congruent, CPCTC. So, on your exam, there will be a straightforward proof like this. It doesn't mean it's going to be an angle bisector and perpendicular and reflexive, but any of your straightforward mini proof definitions, vertical angles are reflexive property, it's going to be a straightforward one. That brings us to number 5. So number 5 wants me to prove that triangle MLO is isosceles. Well, I'm always proving triangles are congruent. So is it obvious which triangles I'm proving are congruent? It is to me. The blue and the green. So statements, reasons. OI is the perpendicular bisector of ML. Given, well, there's two definitions there. There's perpendicular and there's bisector. So I'm going to say that perpendicular lines form congruent right angles. There they are. Angle MIO is congruent to angle LIO. Make sure that I is in the middle. And then I also have bisector, a line bisector, or you can say perpendicular bisector. Either way, creates congruent segments. So I've got MI is congruent to IL. I got two pairs of things congruent. I'm out of givens. I move on to my additional tools. Boom, there's reflexive property. IO is congruent to IO. Reflexive property. Now that I have three pairs of things congruent, I can state that the triangles are congruent. Triangle MIO and triangle LIO. I've got side angle side. And now I pause. Again, I'm always just programmed to prove triangles are congruent. Now I can start thinking. If I want to prove that triangle MLO is isosceles, this purple triangle, I need either two sides or two angles to be congruent. Well, now that the blue and the green are congruent, I can state any of the corresponding sides are congruent, including MO and LO. And if those two sides are congruent, then it makes the purple triangle isosceles. So it's two steps. Now I can state that MO, that was a little too sloppy, and getting to the bottom of the page here. MO is congruent to LO by CPCTC. And now that those two sides are congruent, now I can state that triangle MLO is isosceles And I would say I prove that it has two congruent sides. So an isosceles triangle has two congruent sides. If you notice on the review sheet, you have one example for proving isosceles and one example for proving parallel. I'm not going to give you both, but I am going to give you one. I'm not going to go over the beginning of this proof. I know I want to prove that the triangles are congruent. So if RS and PV bisect each other, those are congruent, and those are congruent. Vertical angles are congruent. And I'm going to pick it up at the triangles being congruent. Statements, reasons. I'm going to pick it up with, I'm just going to call it step 1, 2, 3, 4. I think this will be step 4. Again, do not do this on your test, but I'm not going to go over the whole thing right now. Triangle TXR is congruent to triangle VXX. And that is SAS. So now I want to prove that the lines are parallel. In order for lines to be parallel, I need either alternate interior angles to be congruent, alternate exterior angles to be congruent, or corresponding angles to be congruent. So I need to use CPCTC to get one of those three things. Well, if these triangles are congruent, then this and this must be congruent. And if those are congruent, those are alternate interior angles, which would make the lines parallel. So 2 steps. First, I have to state the either alternate interior, alternate exterior, or corresponding angles. Angle RTX is congruent to angle SVX. And that's CPCTC. That's not alternate interior angles. The reason that those are congruent, if those triangles are congruent, those are corresponding angles of those triangles. And now, those happen to be alternate interior angles. I can state that TR is parallel to SV. And the reason parallel lines cut by a transversal create congruent. They're both inside. That makes them alternate interior angles. So both proving isosceles and parallel, you always have 2 steps after the triangles are being congruent. You have to use CPCTC to get either 2 sides or angles for isosceles, or alternate interior, alternate exterior, or corresponding angles for parallel, and then you can state what they want you to prove. Which brings us to triangle proofs with additional tools, 7 and 8. One of these has addition subtraction property. One of these has isosceles triangle theorem. I'm probably not going to give you both, but you are going to be responsible for both, and you'll see one of them. Is it obvious which triangles I'm proving are congruent? I'm going to say yes. I see the blue, and I see the green. So I start with the first given, ZE is perpendicular to EU, and sometimes perpendicular comes in pairs, so I'm going to state the other perpendicular as well. Given, I know that perpendicular lines form congruent right angles. So there's one, there's the other. Angle ZEG is congruent to angle SUM. And there's different ways to name it. Just make sure that the E is in the middle and the U is in the middle. I've got one pair of things congruent. I move on to my next given because I need 3. So now I've got ZE is congruent to SU. That's a gift. Those are sides of the triangles I'm trying to prove. Given. 4. EMGU given. Are those sides of the triangles I'm trying to prove? They're part of it. EM is part of EG. GU is part of MU. When they give you part of what you need, that's when we use addition subtraction. So it's a 3-step process. I have EM. I want EG. What do I need? MG. On the other side, I have UG. I want UM. What do I need? MG. So the second step is what I need. In this case, MG is congruent to MG. In this case, the reason those are congruent is reflexive property. And now what I want EG is congruent to MU. Now, I must say, or where did EG come from? I basically added these. EM plus MG equals GU plus MG. What did I do? I added them. That's addition property. When you need more, that's addition property. And when you have too much and you need less, then that's subtraction property. So that whole process gave me one thing. Now I have 3 pairs of things congruent. I can state the triangles are congruent. Triangle ZEG and triangle SUM. Triangle ZEG is congruent to triangle SUM. I've got side angle side. And then I can ultimately state what they want me to prove, which is angle Z is congruent to angle S. Oops. Angle Z is congruent to angle S, and that's CP. So what was different for this one compared to the first proof that we went over is the addition property. You need to know how to do addition or subtraction property. If you don't, practice it, but you really need to know it. All right, we get another additional tool proof. I'll do it just because, again, the additional tool is different. You're responsible for both. Is it obvious which triangles I'm proving are congruent? It is to me. I really only see 2 triangles that I could possibly be proving congruent, the blue and the green. So, statements. Reasons. CA is congruent to CB. Given. Now here's the big question. Is CA a side of the triangle I'm trying to prove? And the answer is no. So why did they give it to me? Well, let's go through our additional tools. VRIASV. Does it have anything to do with vertical angles? No. Anything to do with reflexive property? No. Anything to do with an isosceles triangle? Yes. If those are congruent, that makes this an isosceles triangle. And an isosceles triangle not only has 2 congruent sides, but it also has 2 congruent angles. And those are angles of the triangle I'm trying to prove. So I can state that angle RAD is congruent to angle SBD. I can say isosceles triangle theorem. Or I can say in a triangle, congruent angles are opposite congruent sides. I've got 1 pair of things congruent. I move on to my next given. AR is congruent to BS. AR is congruent to BS. That's a gift. Those are sides of the triangles I'm trying to prove. Now I got two pairs of things congruent. 4, I got perpendicular again. So since there's two pairs, I'm going to put them together because I'm usually going to use them both together. DS is perpendicular to BC. Given perpendicular lines form congruent right angles. So DR and AC meet here. That's the angle of the triangle. That's the angle of the triangle. Angle BSD, ARD. Angle BSD is congruent to angle ARD. I've got three pairs of things congruent. Great, I did it. I can now state that triangle ARD is congruent to triangle BSD. I've got angle side angle, two angles and the side between them. And now that I have the triangles are congruent, I can state any of the corresponding parts are congruent. In this case, DR is congruent to DS. Corresponding parts of congruent triangles are congruent. So again, what made this not a basic one is your isosceles triangle theorem, which really isn't that hard as long as you look for the isosceles triangle. That's it for proofs. Because I know this is a harder topic and some students really just don't get proofs very well, I did put some older topics on it as well. We've got a complex triangle problem. Look for linear pairs. Look for angles of a triangle, both of which add to 180. If they give you congruent, mark the sides, mark the angles opposite them. If they give you equilateral, 60, 60, 60. So ADB is equilateral, 60, 60, 60. If DB is congruent to BC, I mark those sides. I mark the angles opposite them. I look for linear pairs. There's one right there. 180 minus 60 is 120. I look for angles of a triangle. I see a triangle. I know the angles add to 180, so since these two are the same, I do 180 minus 120 is 60. And then since those two are the same, I divide 60 by 2 to get 30 and 30. Angle C is 30. Very important. We did that in Unit 1. So you'll have one of those in your test. Number 11, regular polygon rotations. Line of reflection equals line of symmetry. Center rotation equals center of shape. Min rotation is 360 over n, and any multiple of that. We need to start by finding the minimum rotation, which is 360 over n, in this case 360 over 5. Use a calculator if you need to. That's 72. That's the minimum rotation. I don't see that there. Any multiple of that will also map it onto itself. So 60 is obviously not a multiple of 72 if it's smaller. Is 108 a multiple of 72? No. Is 216 a multiple of 72? Yes. Is 540 a multiple of 72? No. Which one is a multiple of that minimum rotation? Choice 3. Because 72, the minimum rotation, times 3, gives me 216. So you'll have one of those in your test. And one more review question. Which of the following cannot make up the three sides of a triangle? Well, the rule for the sides of a triangle is the two smallest sides must add to be greater than the third side. So in choice 1, the two smallest sides are 3 and 4. Did those add to be more than 5? Yes. In choice 2, the two smaller sides are 2 and 2. Do those add to be more than 3? Yes. In choice 3, the two smaller sides are 5 and 7. Do those add to be more than 9? Yes. In choice 4, the two smallest sides are 1 and 4. Do those add to be more than 6? No. 1 and 4 is 5. 5 is not more than 6. That cannot be true. And they can't be equal. They have to be greater than. Not equal, but greater than the third side. So have one of those on your exam as well. Listen, you need to know how to do triangle proofs. There's a lot to it. We talked about all of it. Always prove 3 things congruent. To get your 3 things, do mini proofs, then move on to your additional tools. BRIAS, know how to do vertical angles, reflexive property, isosceles, addition and subtraction, know how to prove parallel and isosceles using CPCTC, know how to do your perpendicular, bisector, multiple choice. And then again, you have some nice little bonus gift questions from older topics, which are not so hard, to rack up some points. Practice, 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 and then practice. Bye.